This is Mrs. O'Neill for AP Chemistry, Chapter 8, Section 1. Chapter 8, the basic concepts of chemical bonding. Refer to page 321 for those key terms that you should know the definitions of. Whenever two atoms or ions are strongly held together, we say there is a chemical bond between them. There are three general types of chemical bonds: ionic, covalent, and metallic. This structure is, oh boy, atomium, however you want to say that, for the 1958 World's Fair in Brussels. The 9 spheres represent atoms, and the connecting rods evoke the chemical bonds holding them together. One sphere sits in the center of the cube, formed by the other 8, a common arrangement of the atoms in metallic elements such as iron. So section 1 is about Lewis symbols and the octet rule. Your objective in this section is going to be describing the three main types of bonds, ionic, covalent, and metallic, and how the how they bond by the Lewis symbols, which is a shorthand for keeping track of those valence electrons of each of the atoms. So now you know where all the electrons are, because we talked about that. Which ones are really the important ones? Hopefully you said the outermost or the valence electrons. So at this point, remember you want to pause, fill in the blanks in your packet, and then play to hear my words. So you should know that a Lewis symbol is the element and then however many valence electrons it has. One thing we want to make sure that you understand or remember is that one dot goes on each side of the element symbol before you start pairing up the electrons. And remember, there's a periodic trend, right? The group number basically represents the number of valence electrons. So here's the trend on the periodic table. Again, I do not represent groups 3 through 12 because they vary with valence electrons, so those do not have any particular kind of trend, but everything else does. So when you go from 13, it has 3, 14 has 4, 18 has 8, with the exception of helium. We want to keep that in the back of our mind too. Helium is that exception to the rule where it only has one energy level and there's only 2 electrons on that first energy level, and they're going to be grouped together like that as a bond, showing that it's already stable. Again, you can also use the electron configuration to help you how many valence electrons there are. So if we look at this group of elements, it's the second energy level. So the second energy, S1, would be 1 valence electron, S2 would be 2 valence electrons, but again, when we go down here, we have 2 and 2, we have the S's and the P's, and that would be 4 plus 2 gives us the 6 valence electrons. In this group, this would be the third period because their third energy level would be their valence electrons. So 3s1, 1 dot, 3s2, 3p3, again would be 5 dots. So, and again, look at the arrangement, 1 dot on each side before pairing up. So the octet rule tells us that every atom wants to acquire 8 valence electrons in some way to become stable. And again, we want to go back and refer to the electron configuration. They're always in the S and the P. So that's part of the S and the P group on the periodic table. Okay, see you in class.